Hello class, welcome to another most interesting aspect of our studies on polynomial functions, which is about division of polynomial functions. And at this studies, we get to know how we perform division operation using long division or synthetic division when it comes to functions. So here, let's come to the next section of understanding polynomial division. How do we understand polynomial division? And listen to this. A polynomial f of x can be divided by another polynomial g of x, provided the degree of f of x is greater than or equal to the degree of g of x. So it means that the polynomial division is only possible between function f of x and function g of x, provided the highest powers of f of x, that is the degree of f of x, is greater than or equal to the highest powers of g of x, that is the degree of g of x. So the polynomial division is being expressed as f of x divided by g of x, or f of x divided by g of x, or over g of x in this particular format. And this is only possible if the degree of f of x is greater than or equal to the degree of g of x. This thing has to be in mind before you perform polynomial division. And listen, f of x is known as the dividend, and g of x is also known as the divisor. So the division f of x divided by g of x can be written in a long division form as. So let's look at how we perform the long division expression, or how we write the expression in a long division format. So here it is going to be the dividend, which is the f of x, divided by the divisor, which is the g of x, equal to quotient, being here the long division rule, that is the symbol for the long division. Inside it will be the dividend, outside will be the divisor, and the down here will be the remainder. So look at this particular expression very well. Then, per the understanding we have from the long division expression, the division of the polynomial can also be expressed as the dividend over divisor equal to quotient plus remainder divided by the divisor. So let's look at a numerical example in the form of an improper fraction here, which is 13 on 5. And this thing can be expressed in a long division format as 13. Then the 5 is here. So here 5 goes into 13. 13 divides 5 2 times. And this 2 times the 5 will give us minus 10. That is how we perform long division operation. So the 13 divided by 10 will give us remainder 3. So this expression, which is an improper expression here, can also be simplified or expressed as the one that you see here. At this point, 13 divided by 5 from our operation or from our analysis is going to be equal to 2 plus 13 on 5. And the 2 here is the quotient. The 5 is the divisor. Then the 3 is the remainder. So when you compare this expression and this particular expression, they look alike. So the dividend becomes the 13. The divisor becomes the 3. Equal to means that both the left side and the right side are the same. The quotient is the 2, remainder is the 3, the divisor is the 5. And since the LCM is 5, it can also be brought down into a simplest form in this particular format. At this point, this is the dividend, here is it. The quotient, here is it. The divisor, here is it, plus the remainder. So polynomial division can be expressed in this particular format, where the dividend equal to quotient times divisor plus remainder. Good. So now let's look at the steps to perform polynomial division. We have the long division method. So here, if I want to perform the long division method, let's use this example to understand these particular steps. We have x cubed minus 5x squared plus 4x minus 3 being divided by x minus 2. The step 1, the terms in both the dividend and the divisor are arranged in descending powers of x. So when you look at this one, these are the terms in the dividend, these are the terms in the divisor. First, the dividend should be arranged in descending powers of x. That means the highest powers of x is supposed to be the leading term. So here x power 3 become the leading term, 5x squared the next, plus 4x minus 3. Then here we have x being the leading term minus 2. Then the next step, the first term of the dividend. So come here, the first term of the dividend is x power 3. Is then divided by the first term of the divisor. So the first term of the divisor is x. So x cubed divided by x to obtain the first term of the quotient. So x cubed divided by x equal to x squared, and the x squared becomes the first term of the quotient. My next step is we then multiply the divisor by the first term of the quotient. So the divisor, which is x minus 2, will be multiplied by the first term of the quotient. So x cubed, x squared rather, times x minus 2 will give us x cubed minus 2x squared. Then the next step is subtract the results in step 3 from the dividend. So we are going to subtract the answer we got in step 3 from the dividend. So the dividend minus x cubed minus 2x squared. And sorry, our answer will be minus 3x squared plus 4x minus 3. And this expression becomes our new dividend. Then repeat the process again until the degree of the divisor is less than the degree of the degree of the remainder, rather, is less than the degree of the divisor. So we look at this remainder. The degree of this remainder is 2, but the degree of the divisor is 1. It means we are not done. So this one will not be our remainder, but it's going to be our new dividend. And we are going to repeat the process over and over again until we get to the main point where the remainder degree will be less than the divisor degree. Now, let's go to the summary of the steps of what we just did. So here we have the dividend arranged in descending powers of x. The divisor arranged in descending powers of x. The first term of the dividend, x cubed, divide the first term of the divisor, x, to obtain the first term of the quotient, x squared. And after that, the x squared will multiply the divisor, x, and minus 2. And our answer is going to be x cubed minus 2x squared. Since we want to complete the polynomial, we are going to add the rest of the terms in zeros. So the terms now will be 0x plus 0. So we are going to subtract our results from this side from the dividend. Then here is going to be x cubed minus x cubed minus 3x squared. If you remember addition and subtraction of polynomials in a vertical form, that is what we are operating, or we are acting here. That is what we want you to understand. Then the understanding is coming from the addition and subtraction of polynomial function in the vertical form. Here, minus 5x squared minus 2x squared will give us 4x. Then 4x will give us minus 3x squared rather. Then we have 4x minus 0x will give us 4x. Minus 3 minus 0 will also give us minus 3. So this one becomes our new dividend because the degree of this one is still greater than the degree of the divisor. We have to get to the point that the degree will be less than the degree of the divisor. So the process will be repeated. Here, the first term of the dividend, minus 3x squared, we divide the first on the divisor, then that will give us an answer minus 3x. So minus 3x times x will give us minus 3x squared. Minus 3x times minus 2 will give us positive 6x. Then the rest of the constant will be with 0, will be added as a 0. So here, let's maintain our stand by dividing the result from the dividend. So minus 3x squared minus 3x squared will give us 0. 4 minus 6 minus 2x minus 3 minus 0 will give us minus 3. Good. So here, this one becomes our new dividend. Still, the degree of this expression is equal to this. We don't want equal to, we want less than. So we have to continue. So the next stage will be repeating the same process. So minus 2x divided by x will give us minus 2. Good. Then minus 2 times x will give us minus 2x. Minus 2 times minus 2 will give us positive 4. So here, minus, we divide, we subtract the result from the dividend. So here, minus 2x minus 2x will give us 0. Minus 3 minus 4 will give us minus 7. So when you look at this particular new remainder, the degree is 0, and this one, the degree is 1. So it means that the degree of the new remainder is less than the degree of the divisor. So now we have to pause operating on this particular expression. It means that we are done with the division of the polynomials between the function s cubed minus 5s squared plus 4s minus 3 and s minus 2. So our expression or our answer is going to be written in this particular form. So it means that dividend over divisor equal to the quotient. So the quotient now is s squared minus 3s minus 2 minus the remainder, which is 7 over s minus 2, where this one is the quotient and the minus 7 is the remainder.